Hello, this is my Physics 2 Lab 2, and my name is Lisa Picnic. So short introduction to this lab. In this experiment, we did the floating tape experiment once again, but now we changed the computational model to better reflect what was truly happening. So previously, we modeled the two pieces of tape as point charges and calculated the electric force by equating it to the gravitational force going down. And then in this experiment, the computational model was set up to model the pieces of tape as a line of charges, specifically 100 in my glow script model, and the total electric field was calculated by adding up these small electric fields and getting the total electric field, and then setting it equal to the gravitational force once again. And then the results from this experiment were the electric force was equal to 1.96 times 10 to the negative third newtons, and then gravitational force was equal to our electric force, and the Q, the charge on the tape, was found to be 2.924 times 10 to the negative 8 coulombs. Some of the physics concepts that were utilized in Lab 2 are very similar to the physics concepts utilized in Lab 1. So this includes Coulomb's law to calculate an electric force, which is F equals K Q1 Q2 over R squared. And then the new concept that was introduced here was separating the pieces of tape into tiny point charges instead of just one point charge, and having glow script add up each individual electric force to get the total, instead of just assuming that each tape was a point charge. And this is known as the concept of superposition. Some of our assumptions and our results again, we ignored air resistance, and then the charge on the tapes was evenly distributed, and the tapes could be separated into segments with equal charge on each segment, and then the sum of the small charges will equal the total charge on the tape. And then the magnitude of the charge on one piece of tape was found to be 2.924 times 10 to the negative 8 coulombs, and this is again from my glow script model. And then on the right, we have a force diagram of the pieces of tape. We have our gravity going down, and then we have our electric force going out, since the two pieces of tape repelled each other. So here we have the physical experiment, Lab 1 recap. This is the exact same data that I had in Lab 1. We have the length of the tape, the mass, the distance, and then the gravitational force was found to be around 0.00196 newtons. And the electric force was also found to be that same value, since that's how the floating effect was achieved. And from this, the electric charge was found to be 1.24 times 10 to the negative 8 coulombs, which makes sense, but is quite different from what was found from the glow script model. Here is my glow script model. We have our constants that I used on the left here, and then we have our function for an electric field on the right, which is exactly the same function I used in my Lab 1. It was just utilizing Coulomb's law and the basic formula. And then the computational model continued here. We see that we have our superposition principle being utilized in this loop where the electric force was found on point charges and they were added up and the arrows were graphed in our model. And here you can see our model, all of the charges. We can see here I used 100 of them, and then we see the total electric force going up and the total gravitational force going down. And here we can see that these were equal to each other, 0.00196 once again. And that was all for the glow script model. So some additional questions we can answer is, what if you had modeled each of the tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. So in our experimental data, we got 1.24 times 10 to the negative 8 coulombs. And in our line charge model, we got 2.924 times 10 to the negative 8 coulombs. And this was found by guess and check until gravitational force equaled electric force, since we know this had to be true for the tape to be floating. And there's a dramatic difference of 57.6% here. And then why do these estimates differ? What value is more likely to be closer to the real value and why? And to answer this question, the values differ because the point charge model assumes the tapes are just one point charge, and the line charge model splits up the tapes into segments, specifically 100, and adds up each individual segment's electric force. This adds an X component to the electric force and makes the methods of calculation differ. And the line charge model is definitely more likely to produce a value closer to the real value, since this model is much closer to the real life physics of the pieces of tape than the point charge model was. So this was my Lab 2 presentation, and thank you for listening.